Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome to our YouTube channel. Welcome to our Digital Hub channel. So just likewise, we're going to deal with chemistry today, and today is where we're going to see a report for chemistry paper 1 and paper 2 for the year 2019. So this is just a report for the year 2019, not 2023, not is it 2024. Okay, so now basically we will just be dealing with looking at this report. What are the common questions that many students missed, and why and how the questions should be answered? How the question answered, or how was it supposed to be answered during that time? Okay, so just likewise in the year 2019, people the overall marks or the overall mean score dropped from 53.76 to 52.17. That's the overall mean score. So there was just a slight drop. So this showed that there was a lot of questions. There was a lot of questions that students got wrong, in which is not because they have less information. Mostly it's because they didn't use their full brain capacity, that is. So just likewise, we'll start with paper 1. So these are the questions that were poorly performed. For paper 1, we had question 7. We also had other questions like question 19, and we also had question 28. It seems that people didn't like to draw at that time. So those were the overall questions that many people or many students got wrong in the exam. So we'll start with chemistry paper 1, and we'll deal with and we'll see the questions first, and then give out the weaknesses, and afterwards give out the proposed suggestions. Okay, the measures to be put in place in order to improve the performance in future. So let's start with question 7 for Kcse 2019 paper 1. So the question was asking, or was saying, that a solution contains 40.3 grams of substance X or H per liter, in which 25.0 cubic centimeter of this solution require 30.0 cubic centimeter of 0.3 molar sulfuric 6 acid for complete neutralization. So question A, calculate the number of moles of X or H. Okay, we don't know our RAM for X. We don't know the specific element for X. So just assume we have X. So calculate the number of moles of X or H that reacted. Question B, determine the relative atomic mass of X. So the requirements here included the candidates were required to calculate the moles of X or H that reacted, and also to determine the relative atomic mass of X. Okay, so most of the students got wrong or failed to answer this question wisely. It's because they didn't know which mole ratio to use for the X or H. Okay, so once you get to know the mole ratio, that's when it becomes easy to find the number of moles of X or H that reacted. So they failed in this question miserably. So many candidates had challenges in getting the mole ratio. So just likewise here, we've been told that many candidates had challenges in getting the mole ratio, hence unable to use the moles of sulfuric 6 acid to obtain the concentration of X or H. X hydroxide. Don't know which hydroxide is that. So the expected response is this. So basically we have sulfuric, we have X or H. Now X or H means that the valency for X is 1 and OH is 1. So just know that the valency for X is 1. So if you react the sulfuric with the X or H, you get X2 sulfate. So X having 1 and sulfate having 2, it therefore becomes X2 sulfate. So you have X2 sulfate plus water, because if you take acid plus basic, it's salt plus water. So this one was supposed to be aqueous, this one aqueous, and this one is supposed to be aqueous, this is liquid. So you get this. So if you balance it out, you realize that you need to put 2 here so that it balances everything out, so that you can get 2X and 2 hydroxide. Yeah, which it becomes balanced that way. And also here, you need to balance it here by adding 2 as well. So therefore you'll have 4 hydrogens on your right and also on your left. You'll have 2X on your left and on your right. You'll have 1 sulfur on both, and you'll have 6 oxygens on both, also 6 oxygen on the right and on the left. So the mole ratio here was 1:2. So now if you were to search for the moles for sulfuric, because that's the first information that we were given. So the moles for sulfuric was that we had 0.3 molar. So 0.3 molar means 0.3 moles in 1,000 cubic centimeters. So you ask yourself, what about the 30 cubic centimeters that was used? So therefore 0.3 multiplied by 30 divided by 1,000. Now it therefore gives you 0.09 moles. Okay. Yeah. So now since the mole ratio was 1:2, if now sulfuric is 1 and XOH was 2, okay, you are supposed to take 0.09 times 2. So 0.009 times 2, it gives you 0.018 moles. So that is for the XOH, or the X hydroxide. Question B, you're asked about the RAM for X. Okay, which also is very easy. Now we were given the molarity, if I'm not wrong. No, we're supposed to search for the molarity. What we know is that 0.018 moles of X hydroxide is contained in 25 cubic centimeter as per the question. So now let's find out the molarity. What about in 1,000? So therefore take 0.018 times 1,000 divided by 25. It therefore gives you 0.72 molar. So this is the 0.72 molar. Now after getting that, we search for the whole RFM, that is the RFM for XOH. And how do you get it? We usually take your mass, which is in gram per liter, divide by the molarity. Okay, so that's why I changed it into molarities, because the mass was in 1,000 cubic centimeter. Okay, so hopefully you've understood. So mass over moles, which is our mass 40.3 divided by moles 0.72, it therefore gives us 55.972. If you round it off, it should give you 56 gram, so 56 yani. So but we didn't find for X. This is just the RFM, the total RFM for X or H. So what do you need to do? We don't know the RAM for X, therefore let it be X. The RAM for O is 16. The RAM for hydrogen is 1. The RAM for oxygen, remember, is 16, and hydrogen is 1. So it should sum up to the 56 that we found out. That is the RFM for X hydroxide. So X plus 17 equal to 56. So therefore X is equal to 56 minus 17. X is equal to 39. So that was very simple. So the only mistake that the student did here, they neglected the part where they were supposed to search moles using mole ratio. So the advice that was given to the teachers, it included that the teachers should she was supposed to put more emphasis. Even currently, we're supposed to put more emphasis on calculations involving molar solutions, and that's why whenever we are at school, we tend to give the students more questions on moles so that they can get equipped with these questions. So let's not use the questions that we have from one book. That's why in this report also, as teachers, we are encouraged to use more than one book apart from KLB, which is the main textbook. We're supposed to use other books like Spotlight, Made Familiar, and etc. Okay. Nowadays we have many textbooks. Now we have Booster Chemistry and etc. So yeah. So we also advise to present the learners with opportunities for more practice on questions on the mole and related questions like this. So let's go to the other question, which many students got wrong. So question 19 was one of them as well, and especially I think this is the most common topic that is usually tested in paper 1, but still it can come in paper 2 as well, because last year came in paper 2. It's usually tested in paper 2 or paper 1, but mostly paper 1. But now students still fail when given such a question. So this is the aspect of half-life and etc. So you've been given that E of copper or copper to ions is 0.34 volts, and that of zinc or zinc 2 plus, which is aqueous, is negative 0.76. Okay, so draw a label diagram of zinc and copper electrochemical cell. Now in these questions, people were supposed to draw and label an electrochemical cell made of zinc and copper half cells. Now students, instead of drawing that, they drew the one that resemble like electrolysis. So they drew batteries or cells where they were supposed to draw a voltmeter, and they failed to draw a voltmeter. They failed to draw a salt bridge, which they were supposed to do that as well. So the weaknesses include this: majority of the candidates could not draw the cell correctly because they confused it with that of electrolysis, and they used a battery instead of a voltmeter. And this is still a common mistaken question. Kizungu now ngumu siku. Yeah, commonly mistook question. So therefore, students should still be very prudent to such questions. So expected response. So this is the actual answer. So the students were supposed to draw the voltmeter. They were supposed to show which one was copper, which one was zinc, and also they were supposed to show the zinc 2 plus, okay, and the salt bridge. You can also write potassium nitrate instead of the salt bridge. You can get a correct mark for that. So the main objective was this, okay. So the salt bridge and the zinc and the copper. So this is the advice to teachers. Teachers were advised to apply practical approach when handling the topic electrochemistry. Okay, so that learners can be able to see the electrochemical cells practically and to be able to see how the cells are made, rather than just showing them on the diagram using books. But it's sometimes better either you show them through the video or go to the lab and show them how it looks like. So it gives a picture to the student, or it puts a picture inside the brain of the students, and as a result they get to remember faster. So we have another question here, question 28 of the same paper, where you asked to draw in the space provided provide a label diagram of the setup of the apparatus that can be used to electrolyze molten lead to provide. Now again, Students don't like to draw, and this is where drawing is needed. But our students tend to ignore such questions. I don't know why, and that's why teachers advise always to make sure that students draw, especially the diagrams, the apparatuses, the tests for different gases, etc. Yeah, and also the experiments that we do from the books, where we advise the students to draw rather than looking at the diagram. So when they draw more, that's when they remember that diagram, because learning is through writing. So the more you write or the more you draw, is the more your remembrance, or the more your remembrance will be high. Okay, so therefore we advise to draw. So the requirements for the candidates, they were expected to draw the setup of the apparatus used to electrolyze molten lead 2 bromide. So, but the weakness is the same still. They failed to indicate heat in the setup, which is very crucial. That's why I always tell my students to draw perfectly. Do not eliminate anything in that diagram. So rather than showing heat, they didn't show heat in the setup, and others could not identify the type of electrodes suitable for the electrolysis. So they didn't know where the lead was, where the bromide ions were. So expected responses. So we have graphite. Okay, we have graphite electrodes. These are graphite electrodes, and now this is the molten lead 2 bromide. So you can't have lead 2 bromide by itself and conduct electricity. It either has to be in aqueous state or in molten state. And how is it in molten state? Is when you heat it. So that's why most of the students got wrong in this question, because they didn't indicate the heat to show that this lead 2 bromide will be molten after few minutes. So the electrode that you usually use, the graphite electrode, most of the time you can use platinum. Okay, but it should be a very good electrode. Okay, so we should know that aspect. So encouraging students to draw is very crucial. So just imagine this, just small mistakes will cost you the whole question. So advice to teachers again: teachers should apply a practical approach when teaching electrolysis, so that learners are able to interact with and see the actual setup of the apparatus. So you can't waste your energy. If you're a teacher, you just take your student to the lab, you can check it out. I don't know why most of us I don't know why most of us tend to use the books to show the experiments when we have labs. So let's use the lab efficiently. If you can't use the lab, we have videos, we have projectors. You can use those to show them also. Okay, so that's for chemistry paper 1. So drawing was a big problem to the student, just likewise, and calculation part, especially moles. So still now, students still face the problem of moles and the problem of topics like electrochemistry, which are easy questions and they should be easily answered. So advice to teachers, we've already said it. Now we'll look at the chemistry paper 2. So for chemistry paper 2, there was a question. That question was question 5. Okay. So the question 5 was saying, or was asking, the definition of molar heat of neutralization. So the question was saying what is meant by molar heat of neutralization. Question B: in an experiment to determine the molar heat of neutralization, 50 cubic centimeter of 1 molar hydrochloric acid was neutralized by adding 10 cubic centimeters portions of the sodium hydroxide. So during the experiment, the data in table 1 was obtained. So the first question, so you have the data, you have the volume of sodium hydroxide, different volumes, giving you different temperature. So Roman 1 was asking you to write the equation for the reaction in this experiment, and then you're supposed to plot a graph of temperature y-axis against volume of sodium hydroxide, which you're supposed to be on the x-axis added. So then Roman 3 asks you to determine from the graph the volume of sodium hydroxide, which completely neutralizes 50 cubic centimeter of 1.0 molar hydrochloric acid. Then the other question was asking you about the change in temperature, which is change in T when complete neutralization occurred. Question Roman 4, calculate Roman 1, the heat change or the enthalpy change when complete neutralization occurred, and then the molar heat of neutralization of hydrochloric acid with sodium hydroxide, and how will the value of molar heat differ if 50.0 cubic centimeter of 1.0 molar ethanoic acid was used instead of 1.0 hydrochloric acid. Now you also give a reason for that certain question. So the requirements included. So the question required candidates to apply knowledge on enthalpy changes, to draw a graph of the reaction and deduce some data from the graph. Now the weaknesses, obviously, again, things to do is drawing. Students were very had difficulties in it, and especially in interpreting those graphs or interpreting that graph, they had a huge difficulty. So majority of the candidates were not able to apply the knowledge of extrapolation, so they didn't know that aspect of extrapolation to determine the highest temperature change, but they just used the highest and the lowest temperatures from the table, which you're supposed not to do that. So they just took the highest here and the lowest here. So I think which that was wrong. So they was supposed to extrapolate that diagram. Okay. So also so to determine the enthalpy or the change in temperature, they just used the highest and lowest from the table, where they were supposed to use from the graph. I don't know. So these are questions that at that time they answered it incorrectly. So the expected responses included for the first question, which is question A, the heat change that occurs when 1 molar of hydroxide ions reacts with 1 molar of hydrogen ions to form 1 mole of water. That is molar heat. Okay, they ask you molar heat of neutralization. So molar heat of neutralization is defined as the heat change that occurs when 1 mole of hydroxyl ions, hydroxyl ion react na 1 mole of hydrogen ions to form 1 mole of water. That heat change is what we call molar heat of neutralization. Obviously, no neutralization, the aspect where you get a neutral thing, which is like water or salt. So that heat change, that's why we added the heat in it, molar heat. So it's the heat change that occurs when you take 1 mole of hydroxide ions and react it with 1 mole of hydrogen ions so that it can form 1 mole of water, molar. So the reaction, the equation itself was sodium hydroxide plus hydrochloric acid to give you sodium chloride and water. Very simple. So you don't need to balance because it's already balanced. Also, let me just write in case you haven't seen it then. So sodium hydroxide, plus HCl to give you sodium chloride plus water. So if you see this diagram here, so you're supposed to extrapolate it. Many students just fail there. So this is the diagram. So you have 2 lines. Roman 1, volume of sodium hydroxide. Volume of sodium hydroxide. Let me look at the question. You've been told the volume of sodium hydroxide, which completely neutralizes 50 cubic centimeter of 1.0 molar hydrochloric acid. Okay, 50 cubic of mole hydrochloric. Okay, and the answer was, from the graph itself, you'll see it is 33.5. So this one, okay, this one is your answer, supposed to be your answer. So you drop, this is the point through which neutralization take place. So you drop it to the volume, which is supposed to be around 33.5 there. So and then the other question was asking you about, I think, the change. Yeah. So it was asking you the change in temperature when complete neutralization occurred. So the highest minus the lowest, right? So you tend to take the highest minus the lowest. The highest from the graph was 31.65 minus the lowest being 25. So 31.5. Yeah, okay. Supposed to be somewhere there. So if you look at it carefully, 31.5, I think it's around here. This is 31.5. Yeah. So that's the highest and that's the lowest. So you just subtract these two and it gives you a difference of 6.65 degrees Celsius. We got it from the graph and not from the table. And then we asked about getting the heat change, I think. Yeah, the heat change when complete neutralization occurred. Sorry for that. So the answer for that also was 2332.155. So yeah, but I think my main concern is not calculating these ones, because otherwise I could have calculated this long time ago. By just my concern was you just find by yourself, just get time to answer, to look at the paper and answer these questions. But my main concern was on the weaknesses of the students. So they failed at identifying the change in temperature. They also identify in locating the neutralization point and etc. Now for the last question, it was asking about ethanoic acid. So let me answer that for you. So the last question was asking you how will the value of molar heat differ if 50 cubic centimeter of 1.0 molar ethanoic acid was used instead of 1.0 molar hydrochloric acid, right? And the answer is, so the molar heat of ethanoic acid will be lower. It will be lower. This is because ethanoic is a very weak acid. So since it's a weak acid, some of the heat energy is utilized in ionizing the acid. And thus not some of the heat energy is utilized in ionizing the acid. So it's opposite to a strong acid. So a strong acid uses most of the heat in ionizing that acid. But for a weak acid, the reaction itself is very slow. So therefore, the molar heat will be lower. Okay. So just find time to do these questions, but I think it's not that hard. Okay, you either get it from the graph. I think you can get it from the graph if it's possible, or you can calculate it out by yourself by taking 83.5 times 4.2 times 6.65. But now, yeah, these are values from the graph itself. The 6.65 is your change in temperature. And then you have the 83.5 and the 4.2. And I think we were given there. So the 4.2 was the specific heat capacity. And we just multiply those three. So 83.5 times 4.2 times 6.65. Okay. So, yeah. If you're asking how to get 83.5, just take 50 plus 33.5. So for the other questions, also try your level best to look at it, because it's a very important question and is usually commonly asked in the exams. So the advice to the teachers they were supposed to guide the learners on skills for drawing graphs. Okay, how to interpret those graphs, especially we shouldn't teach our students on just on how to draw graphs. We also need to teach them on how to interpret those graphs. This is a very key concept that we lack amongst ourselves also. It's very sad to say that, but we lack that concept. We teach our students to draw graphs rather than teaching them also on how to interpret it and how to apply it in life. Right. Now, just recently I got a student and he drew, because I also teach maths. I'm majoring in both maths and chemistry. So I told him to draw a histogram. So when he drew a histogram, he drew a perfect histogram. But now, there's the surprising fact was he didn't know how to interpret it at all. Okay, he didn't know how to draw a frequency curve. He didn't know which one had the highest frequency, and he drew it perfectly, but he didn't know how to interpret it. So at the end of the day, I gave him 5 marks, but still it doesn't make sense. You're drawing something and you don't know how to interpret it. You don't know what that graph stands for. So when you finish high school and go to university, it becomes a very difficult thing it becomes a very, very difficult thing when you are in university level, because you use those approaches, especially when you do your research papers and etc. You need to have that knowledge in your mind. So what is the use of me teaching you on how to draw a graph and you don't know how to interpret those graphs? Just because of handful marks, it's better I teach you the whole thing rather than teaching you only bits of it. So yeah. So the last question was about rate of reaction. So the question was asking you about rate of reaction. So what is meant by rate of reaction? Question A. Question B. In the space provided, sketch the diagram of a setup that can be used to determine the rate of reaction between manganese oxide and hydrogen peroxide. And question C. A student places a small amount of liquid bromine at the bottom of a sealed gas jar of air, as shown in figure 4. Now let's finish up. So for Roman 1, you've been asked to describe what will be observed after 2 minutes. Roman 2 after 30 minutes. And then Roman 2 use the kinetic theory to explain the observations. Roman 1 after 2 minutes. Roman 2 after 30 minutes. And question D, some plants have seeds that contain vegetable oil. Roman 1 describe how the oil can be obtained from the seeds. Roman 2 explain how it could be confirmed that the liquid obtained from the seeds is oil. So the requirements here, the candidates are required to define rates of a reaction, draw a setup that can be used to investigate the rate of decomposition of hydrogen peroxide using manganese oxide as a catalyst, and also to describe the observations made when bromine liquid diffuses. Okay, so so obviously the expected responses. Now I don't see the weaknesses, but mostly the weaknesses is still the same. The students failed to draw, so most of them did not know how to draw the setup itself. They didn't know what to put in that setup. So what to include in that setup was a challenging factor for the student. So now rate is usually reaction rate is a measure of how much of reactants are consumed. Okay, it's just that, or how much products are formed per unit time. So it's just changing concentration of reagent or time. So it's just measuring how much reactants are consumed or how much products are formed per that unit time. So that is why we call it a reaction rate. So because reaction is usually it usually looks at the products and also at the reactants. So by how long or what rate will those reactants be consumed and at what rate those products will be formed. Okay, now this is the diagram itself. You're supposed to include a syringe, and also this is the mixture of manganese oxide and hydrogen peroxide. Okay, afterwards I think you can get oxygen. So workability, you are already with 1 mark. Means of measuring the gas also, and the means will include the syringe, and means of timing it. So you are supposed to include a stopwatch also on the diagram. Okay. For the other question, if I'm not wrong, yeah, let's look at the question. So you have this liquid bromine, which is at the bottom of seed gas jar of air. The first question was asking you describe what will be observed after 2 minutes and also after 30 minutes, and also use kinetic theory to explain this observation after 2 minutes and also after 30 minutes. So after 2 minutes, what will have happened? The red-brown color fumes of bromine are observed on the surface of the bromine liquid. Okay, and after 30 minutes, the gas jar is filled with yellow fumes. Okay, so yeah. So the reasons. So usually bromine liquid is volatile. Is in terms of explaining in terms of kinetic theory. So bromine liquid is volatile. So the molecules escape from the liquid, but the vapor, being denser than air, will occupy space on the surface of the liquid. That is the reason why you saw a red-brown color fumes after 2 minutes. But after 30 minutes, you've been told that the gas jar is filled with yellow fumes. The reason behind it is because since molecules in the vapor phase move randomly with time, so bromine molecules will undergo collisions with air molecules and mix. That's why it fills the whole gas jar. And the last question is focusing on describing how the oil can be obtained from the seeds, and also explaining how it could be confirmed that the liquid obtained from the seed is oil, which is very simple. Now, for you to get that oil from the seed, usually we take a mortar and a pestle. We crush that seed with a mortar, inside a mortar with a pestle, so that you can increase the surface area for oil extraction. Then add a solvent which is suitable for it with continued crushing. Make sure you crush and add solvent at the same time. So afterwards, after doing that, the liquid is then decanted into an evaporating dish, and the evaporating dish is placed out in the sun to allow the solvent to evaporate because of its low RMM. Okay, so you just leave behind the oil. So the solvent will evaporate, you just have the oil. Once you have the oil, now, okay, obviously, once you have the oil and you want to confirm if that is an oil, then that's where we go to section 2, question 2, Roman 2. So the liquid which is left after evaporation, which is the oil, is placed on a piece of paper. So if you see a translucent mark, then it is oil. Otherwise, if it is transparent, it means that the solvent is still there and the oil is not there. Okay, so again, we should use a practical approach when teaching rates of reaction and diffusion in air, so that they can see how air diffuses and how liquids diffuse or solids. So with that all, I don't have much to say. Okay, I just wish the best luck to your examination, because I think the exams are approaching very near. So don't forget to subscribe to Mewa Digital Hub. Again, always telling you to subscribe to this channel. Okay, yeah, subscribe to this channel. So with that, all in all, I'll leave you there, and I'll also greet you by saying Assalamu alaikum wa rahmatullahi wa barakatuh.